Fiberglass composites fiber-reinforced polymers, or FRP, are used in civil construction for structural reinforcement, corrosion resistance, and energy efficiency in applications like bridge decks, rebar, facade panels, roofing, and water pipes. Their lightweight, high-strength, flexibility, and resistance to environmental conditions offer an advantage over traditional materials, enabling innovative designs, faster installation, and longer-lasting structures, thus offering a long lifespan with minimal maintenance requirements. Other salient features include flexibility and design freedom that allows for complex shapes and designs which are not easily achievable with conventional materials. Fiber-reinforced composite structures are energy efficient as these possess integral insulation properties which contribute to energy-efficient buildings. The lightweight nature and ability to prefabricate panels can significantly speed up the construction process. This lecture is a comprehensive overview of its use in civil works. How fiberglass works in civil construction includes its use as components where FRP composites consist of strong, lightweight fibers like glass fibers embedded in a polymer resin matrix, for example epoxy. These prefabricated materials are applied to the surface of a structure and bonded with an adhesive resin. The FRP acts as an external reinforcement, significantly increasing the load-carrying capacity and overall stiffness of the weakened or damaged structural element. Structures fabricated with fiber-reinforced composites provide excellent strength while being lighter than steel, which reduces the load on foundations and allows for more daring designs. These are superior to traditional materials in resisting chemicals, water, and environmental factors, hence known to be more corrosion-resistant than cement and alloys. Insulating properties of these materials make them promising candidates for green environment applications. In light of properties shown on the screen, FRPs have a high strength-to-weight ratio, meaning they add minimal dead load to the structure. Unlike steel, FRPs are highly resistant to chemicals and corrosion, making them ideal for harsh environments. FRP composites possess superior tensile strength compared to steel by weight. These have been tested for long-term performance in demanding conditions. They can be molded into complex shapes and are suitable for various applications, including strengthening concrete, masonry, and timber. Pre-cured laminates or fabrics are bonded to the surface of the structural member as externally bonded reinforcement EBR. Near-surface mounted FRP bars or strips are installed into grooves cut into the concrete surface, then filled with an adhesive. Environmental and economic benefits are evident from their low maintenance costs over the whole lifespan, as almost negligible repair is needed. These materials are almost completely impervious to humidity and other weather elements. Another important point to note is that these materials can be recycled by extracting glass from fiberglass composites. In addition to this, fiberglass composites easily find their way into cements and rubber products after recycling at the end of life. Glass fiber reinforced polymer GFRP rebars are used as a substitute for steel. FRP can be a substitute for steel rebar in concrete, providing corrosion resistance in harsh environments like chemical plants or wastewater treatment facilities. For structural strengthening, composites are utilized to repair and strengthen existing structural elements such as columns and bridge decks, especially after damage from seismic events or degradation. Beyond buildings, FRP is employed in bridges, used in bridge decks, elements, and as structural members. Concrete bridges repair and strengthening piers and decks, according to NIH standards, are easily achieved. These provide enhanced strength and stiffness to historic or weakened masonry structures. These are applied in industrial structures and widely used in marine environments or chemical plants where corrosion is a major concern. Structural strengthening with fiberglass composites or FRP composites involves applying fiberglass fabrics or laminates bonded to existing structures to enhance their strength and stiffness, particularly for concrete, timber, and masonry. This technique is used to improve flexural, shear, or seismic resistance and offers advantages like corrosion resistance, high strength-to-weight ratio, and lightweight properties, which increase structural capacity without significantly adding to the dead load. Common application methods include externally bonding EBR sheets or using near-surface mounted NSM bars, and the process often involves impregnating the fibers with a strong polymer resin such as epoxy. Fiber-reinforced concrete plays a major role in increasing the strength of the structural components in which it is affixed to old and new structures. Beyond buildings, FRP finds use in pipes and tanks as these are suitable for piping and water treatment in chemical plants due to their chemical resistance. FRP are found in gratings, walkways, stairs, and other secondary structures where its corrosion resistance and strength are beneficial. Fiberglass composites, known as glass-reinforced plastic or fiberglass-reinforced plastic, are widely used in the fabrication of pipes and drainage systems for a variety of demanding applications. The composite material combines glass fibers for strength and a polymer resin matrix for corrosion and chemical resistance. These are prepared through filament winding or centrifugal casting or simple hand layup techniques. Fiberglass reinforced plastic or FRP composites are widely used in architecture for claddings and dome structures due to their design flexibility, high strength-to-weight ratio, and exceptional durability. They are a versatile alternative to traditional materials like concrete, steel, and wood, especially for complex and intricate designs. Glass fiber reinforced polymers are used in tunneling and underground construction as an alternative or supplement to traditional steel reinforcement. Their corrosion resistance, durability, and cuttable nature make them ideal for mitigating project risks and reducing long-term maintenance costs in harsh underground environments. It is used to reinforce precast concrete tunnel segments which form the structural lining of tunnels. GFRP rock bolts are a primary application used to stabilize rock formations and prevent collapses in tunnels, mines, and underground excavations. Despite the benefits, the use of GFRP has specific challenges flashed on the screen. Some include higher initial cost versus steel or concrete. Skilled labor is required for installation and design. While research is advancing, comprehensive and standardized design guidelines for all GFRP applications in tunneling are still under development. Research into easy and faster recycling methods is ongoing. It speeds up construction with prefab units. These improve load capacity and earthquake resistance. Extensively used in building restoration and upgrades in stadiums, airports, and museums. Fiberglass composites are easy to mold into complex shapes. Important web links are flashed on the screen. Stay tuned for future lectures on offer from Technology Education and Mentoring Center.